Okay, so for this video, we are going to learn, okay, the natural log function. So what is natural log? Okay, so maybe we have a look for the learning outcome first. So for the learning outcomes today, we are going to learn the definition and also the property of e power x and also log x. So what is log x here? Log x here actually means that log base e. Okay, including their relationship as inverse function and also the graph. So you need to know the inverse function. You need to know that both of them are inverse function of each other. And also you need to know how to sketch the graph, right? So for A-level syllabus, we actually focus more on log function and also e power x instead of the basic log base n. Okay, but no matter how, both log function and everything have the same rules. Okay, just that they are in different base only. Right, so maybe we can have a look for e. Okay, so what's the meaning for e, and what's the meaning for e power 1? E actually is a symbol like pi. Pi, you know that when you press the calculator, right, it is a very long decimal number, which is 3.141592654. And then this number is very long, okay, and then they actually denote it by using a special symbol we call as pi. All right, and then we are using the pi mostly in circle. All right, okay, so circle related to this number very often, so they give it a very special symbol, which is the pi. So the same thing happened for the e here. So e is actually e power 1. So for e power 1, it should be 2.718281828. Okay, so this is the value for e. And then because the number is also very long, with a very long decimal number, so they give it a special symbol we call as e. Alright, so although we didn't write it out as a 1, but you should know it's e power 1. Okay, so why do we have e here? Okay, it is because of when they try to do the differentiation for log function, they realize that the process is quite complicated. Alright, and also for integration, also the same thing. When they do the integration for log function, then they also realize that, hey, it seems like the answer is quite complicated. Okay, there's something left over like this number. Okay, therefore, to make the process of differentiation and integration easier, they change this number to become the e, so that later when we use all the integration and differentiation for the log function, right, that involve the e, it become much more easier. So that's one of the reasons. And then the another reason is maybe when you want to draw, I forget already, is it to draw the graph or whatsoever, like a curve? Okay, so they realize, hey, most of the time this number appeared. And that's why we use it very often, and therefore they make it as a special symbol e. Alright, so if you're more interested, if you're interested in knowing all this, right, I think it will be better if you go and search online. Like, why do we need to have special symbol here? Okay, in maths, right? Okay, so for us, we are going to focus on this value here, e. So again, make sure that you know that e is this number. Alright, and then log base e, log base ex, you can write it as log x, ln x, we call as log x. Okay, so let's have a look for all the details. Okay, so first we call the log base e as natural log function, natural log. So log base ex, we can write as log x. So similar like the log function that we learned before, the value after the log or the value after the log e, it must be always positive. So if you don't believe again, you can try you press log power -3. You'll get a math error. Okay, so the number here must be always positive number only after the log or after the log. Okay, so all the rules here and all the simple property here, right, is actually exactly the same like what we have in the log function just now in the previous video. All right, so you just now you just apply it into the log base e only. Like previously we learned log base b 1 equals to 0. So now you're having ln 1 equals to 0. Ln is log base e. So log base 1 also equals to 0. So ln 1 equals to 0. So please think on this. And then when you're having ln e, it is equals to 1, which is having the same concept as log b equals to 1. Okay, because ln e means log e equals to 1. Alright, so the same thing happens for here. For this one is ln e power to n equals to n. You can put the n in front. And e ln n equals to n. So I think this one you need to memorize it. Okay, because I think in chapter 5, integration later, you'll use this quite often. Like maybe when you are doing the integration, right, you might have ln e ln 3. So you should know that you can actually simplify it become 3. Okay, then now we proceed to the properties of log. Okay, so for the properties of log, also having the same thing now. The power inside the log or ln, you can put it in front, so it becomes n ln x. So the same thing happened for the n root rule. The same thing happened for the multiplication rule and also the division rule. Alright, so all the rules are exactly the same, just that they change the log base b, log of any number become log base e only. And all these are the log. Okay, so they are exactly the same, nothing different, only the base are different. The base is different. Okay, so I'm not going into discuss all this in detail anymore. All right. Okay, so let's have a look for example 3. So example 3, they just want you to change the expression, the equation e power 7 equals to p and make it become logarithmic form. So again, do you remember or not, when you want to change it become the log form, what are you going to do is you change this base number to the other side. So it will become log base e with p. And then the power here, you can pull it down, become a number. So it becomes a 7. So if you want to write it in a more detailed way, log base e is ln. So you're having ln p equals to 7. So you are changing the indices, the exponential function become the logarithmic form. Okay. All right. Then after that, for example 4, they want you to expand every single term here. Okay, so I will leave it for you, okay, to expand it. I'll just write out the final answer here. And also example 5, I want you to try and combine them, become a single log. So again, it is a practice for you also. Try to simplify it yourself. Okay, I will only write out the final answer for you here. So the rules are exactly the same like what we learned just now in the previous video. Right? Okay, so answer for part A. Actually, there's no step now because sometimes when you just expand and write out the answer, there is answer already, no extra step. Alright, so this is the answer for part B. And then for part C, you should have this. And then for part D. Okay, so you can double check and see how you're able to get all these answers here. Alright, and after that, example 5. Okay, so for example 5, I will just write the answer here also. When you combine them, become a single log, the answer that you get should be something like this. Okay, so this one, it might be a bit tricky, but I'll just write it like this. Then the whole thing power 3. Or you can write it become all the power. Okay, so you can write it like this. Okay, so this is how you do it for example 5 and also the answer for example 4. You have to practice it yourself, but because I already explained in detail in the previous video, okay, how to combine and how to expand. So now for you, you have to practice and see whether you understand all the rules or not. Okay? Especially for those who have no background about the log function. Alright, so if let's say you are from SPM background one, I think should be no problem for you to do all this, alright? Okay, then now we have a look for example 6. Okay, so example 6 is a partial question. So May, June 2013, alright, 7 years ago. Okay, so let's have a look. So it is given that they give you this equation here. They want you to express y in terms of x in a form not involving log. So that means your final answer shouldn't have any log function here. Okay, so let's have a look what they give us. So you're having ln y plus 1 minus ln y equals to 1 plus 3 ln x. So again, there are many ways to do it correctly. Okay, so I'm just showing you one of them. Right. Okay, so as what I told you before, if I don't want to have any log function, right, you cannot simply cancel them. Okay, so maybe before that, I should tell you some simple rules first. Okay, so first, when you want to cancel the log, right, you must have the pattern like this. Left hand side got 1 log or 1 ln equals to right hand side got only 1 log or 1 ln, and then in front has no number 1. Okay, so if like this, when you're having an equation like this, then you can cancel the ln both sides. Okay, and then now if let's say you are having ln something, okay, let's say I give you a ln 4x equals to ln 4 plus ln x as an example. All right, simply just a very simple example, or maybe I change a bit. Maybe I change this one become x squared plus 3. Okay, so for this kind of equation, right, you're having ln 4x equals to ln 4 plus ln x squared plus 3. Left hand side got 1 ln, right hand side got 2. You cannot tell me that you want to cancel off the ln like this. This is wrong. Okay, this is correct. You can only cancel them when both sides also got 1 ln only without other thing, and also in front of the ln has no numbers. Then you can cancel off. Then this one you cannot cancel. Alright, okay, so there are some students they are not so sure, so sometimes they will do it wrongly. So you have to always make sure that this one only can cancel, this one cannot cancel. Alright, so maybe one more example. Can anyone tell me whether can I cancel this or not? Ln 4x equals to ln x then plus 3. The plus 3 is outside the ln, not inside the ln. So can I cancel off this and this? Without bother the 3 or not? Can I just cancel the 2 ln like this? Cannot. It is wrong also. Alright, so again, as what I said, when you want to cancel the ln, the only way is left hand side got 1 ln with something else, right hand side got 1 ln with something else. Then there's no plus, minus at the end outside the ln. Then only you can cancel them. Okay? Alright. So now, let us come back to our example here. Okay, so this one. There are so many lns here, so of course I cannot cancel all the ln. So what I'm going to do is that I want to change this equation, become left hand side only got 1 ln, right hand side also got 1 ln only. Okay, so can I combine the left hand side become 1 ln? Very simple, right? Because of minus, so you're having ln y plus 1 divided by y. So this is the division rule that you learned just now. Equals to, okay, for right hand side you're having 1 plus 3 ln x. So to combine them become a single ln, you cannot do it straight away like this. So first you need to change the 1 become something with ln. So 1 is actually ln e. Then plus 3 is a number. So I want to pull it back become the power. So it become x power 3. So I'm having ln y plus 1 divided by y equals to ln ex power 3. So when we combine we are applying actually the multiplication rule. Alright, so now both sides only got 1 ln. Okay, so you can cancel them. So your ln disappear already, no? But now if you follow the question, the instruction of the question, they want y in terms of x. So y in terms of x means that y equals to something something x. Okay, so how can I rewrite it become y equals to something something x? So all these are basic knowledge for maths, basic techniques for maths. Okay, so if you don't know how to do it, you can go back to kindergarten, right? And then come back again after you are okay with it. Okay, so now y plus 1 divided by y, I would like to express it become 1 plus 1 over y equals to ex power 3. Then 1 over y is actually ex power 3 minus 1. And therefore, I will have y equals to 1 over ex power 3 minus 1. So this is the answer for y in terms of x. So all this, no special formula, no special technique whatsoever. It is based on your common sense and also your very basic math knowledge. How to express y in terms of x. Okay, all right. So this is one of the past year question that they asked before. Okay, so I hope that you understand. So all this, we are actually applying all the properties for log function. Okay, so it is quite important. And then this part, all the properties for log function, we are going to use it very frequently in chapter 5 later, which is integration. All right, so maybe you feel that all these are very easy, but later when you go to integration, when you want to apply all these, all right, you might find out that it is quite actually, you need to know quite detailed about all the properties. All right, so make sure you are very clear about all this, how to combine them, how to cancel off the log and so on. Okay, so I will stop here for this video, and then for the next video we are going to discuss how to sketch the graph for log function and also for the exponential function. Right.